In this one, I'm going to teach you how to do buffer overflows blazingly fast, and this is a culmination of all the stuff that I wish that I knew a long time ago, because the reality of the matter is, if you're learning this for OSCP, you only have 24 hours to complete the exam, and let me just say, I've definitely had those experiences of spending way more time on this than I needed to if I knew the tips and techniques that I'm going to show you in this video. And getting this done fast and getting this one knocked out quickly is going to be very helpful to you if the buffer overflow box is one of the ones in your exam set. Now, keep in mind, it might not be. Now, with the changes to the OSCP exam, there is a chance that you don't even get a buffer overflow machine that you have to attack. And if you do, you only get 10 points, right? So the fact that this is only worth 10 points now, whereas it used to be worth 25 points, you don't want to have to spend a lot of time on this machine. You want to just get this one quickly and be able to move on to bigger and better things in your OSCP exam. So that's exactly what I'm going to show you guys how to do in this video. Now, you see there's some things I already did. I already started immunity, and what I did was I went to File, and I went to Open, and I'm going up against, and I open the executable. I'm going up against, just so all you guys know, the Try Hack Me Room Buffer Overflow Prep. I'll link that in the description below after the video so you guys can check it out. It was made by Tiberius, and it's a very good practice for OSCP buffer overflow specifically, because this buffer overflow is almost identical to what you would find on an OSCP exam. And also, as you're pursuing the OSCP and leveling up, you're eventually going to reach a point where you're ready for those job interviews. Maybe even before you get the OSCP, to be honest, like was the case for me. Either way, you're definitely going to want to check out the description below for the top 10 pen testing interview questions that you need to know to ace your next interview. And let me just say, if you're already in this field, this will definitely benefit you as well. I've used knowledge of this to constantly get higher paying jobs and better gigs. So definitely check that out either way. So let's just crack into it. They give us a number of things to start out with. The very first thing that we want to do once we have this here, and let me just expand this here so we can see the memory addresses. Expand some of these columns here. Now, what I want to do first is I want to go down here and I want to set my Mona config working directory. And you'll see why in a little bit why this is important to do. Now, I have notes on this, by the way. This is how I would recommend going through this video. Take your notes along the way. That way, the next time you approach this, you can do it very quickly. You just copy and paste certain things that you'd run every time. So this command here, I'll make it bigger on the screen so you can see. This is what I would run down in this tiny little bar here and press enter. And that will set up my working directory in C Mona. Okay. So now that that's out of the way, we can begin fuzzing this application. So I already have it running. Now, if you're wondering how do I go back to the view I was just at, you just click Window and you click CPU. And now we can see the window we were just looking at. You just align this really quick here. So it's all nice and clean. This is how you'd see it typically. Now, if you're wondering how I made this more readable, by the way, I changed this. I went to Options, Appearance, Fonts, and then I hit Change, and then I changed the font to size 12. That way everything's bigger, more readable. So let's just go ahead and do the fuzzing. Now you could use this script here that Tiberius wrote. I pretty much have it in my notes to copy paste. What I would recommend doing is on Kali, if you set up your views up here, we could go to the second workspace. So let me just click over to workspace 2. And I have this fuzz.py here. I created a fuzz.py and I just pasted in the code. And this is we're going to tackle Overflow 8 on this one, by the way. Just a random one for you guys to showcase it. So now that I have this, I can go ahead and run this. So I'll save it doing a Control S. And we're going to use keyboard shortcuts here. It's going to make things fly around a lot faster. So if I press Control F5, it will run this script automatically. No reason to type stuff in the terminal or anything like that. Just Control F5 and it will begin fuzzing the application. And let's see how many bytes that it fuzzes with until it determines a crash. And it's kind of hanging there and it crashes it at 1800 bytes. Okay, great. So now that we determined that, let's just go ahead and run something from the command line, msf pattern create, and we'll give it 1800 bytes because that's what it crashed at. It's going to generate a unique string that's 1800 bytes long. We'll copy that. And before we use this here, create another one called exploit.py, and we will paste this code in. And we're going to have to change the IP address. And this is just template code that we're working off here. No problem. We'll make the necessary modifications. This is Overflow 8. And yeah, now what we want to do is take this large string, this long string that we found earlier, and copy it. And we're going to put this in at the payload. So we just paste this in here. Everything looks good. So now we can go ahead and try this. But first, we'll make sure to save it. But first, we're going to make sure we go back to workspace 1. And let me show you a fast way to reload this. Now, back in the day, and for a very long time, I am very sad to say this, for a very long time, I would close out of Immunity, reopen Immunity, click File, click Open, find the executable, and then click Run. I would do so much clicking and waiting for things to load. Please don't do that. Okay, please do not do that. There's a much, much faster way to go about this, okay? And it involves some, once again, keyboard shortcuts. You don't have to close Immunity at all. All you need to do is press Control F2, and that will reload that previous one. So basically what that did was it ran this here, the one we just ran. It opened that process. And then we want to run it by pressing F9. So each time we rerun this, we're just going to do Control F2, F9, and then it's going to reopen this process, start it fresh, and then it's going to run it. So we're good to go. We'll go back to workspace 2, and then Control F5. And cool, it sent the evil buffer, done. And if we go here, we see that it's paused because there's an access violation. It crashed the program. So now we want to determine the offset. Now, don't listen to the boomers that tell you to use MSF pattern offset. You could do it in Mona. So the way we're going to do this is we are going to come down to this tiny little window once again. We're going to paste in Mona find MSP tack distance 1800 because that was the number of bytes that we're working with. And it's going to run a bunch of stuff here. And what you're going to see, this is the line you need to pay attention to. EIP contains normal pattern, some address, offset 1786. So that is our offset. So let's just, before I click off of here, let's do Control F2, F9. And we're good to go. Now I come over here and let's make the offset 1786. And let's see if we can overwrite EIP by putting in as our return address 4Bs. And now we just remove this payload here, keep it empty for now, and let's see if that works. So Control F5, workspace 1, and there you go, EIP, 4Bs, that's the /x42 in hexadecimal. So once again, Control F2, F9. Now it's running again, so we're good to go. Now what we need to do is determine any of the bad characters that might be there. So there is a Python script that you can run to generate all characters. So let's just go ahead and create that file, allchars.py, and we'll just paste in this code right here. And yeah, Control F5, run that, and boom. Now we have all the characters in hexadecimal, minus the null byte 00, because that's pretty much always going to be, for string termination, it's going to be a bad character. So if we go back to exploit.py, we could close out of fuzz.py. We don't need that anymore. What we're going to do is in payload, we're going to put in this entire thing here, and we're going to work off that. So let's save this. Now here's the next part. We're going to actually use Mona to determine these bad characters. We're going to use something called the compare function. Using it, we're going to generate a byte array for all characters here. So Mona byte array, and you tell it the bad characters. We're just going to assume the null byte is a bad character. So down here, we put in this and press enter. And there you go. It generated the byte array files here. And what we're going to do is we're going to run this again. So what I like to do at this point is I like to take a notepad and I like to copy to that notepad, because we're going to have to keep running this command over and over. And what I've noticed is that if you try to arrow through these commands, or you can up arrow, down arrow and stuff, it's just really wonky, inconsistent for me. So what I prefer to do is, usually I do it on my host system with the notes. There's a couple commands we're just going to keep running here. So let's just go ahead and try and run this again. So Control F2, F9. It's running. And then we'll just come here, Control F5. And then we come back here. Now what we want to pay attention to is the value of the stack pointer, ESP. We just want to keep copying this. So double click that, right click, and you can say copy selection to clipboard. And you see there the keyboard shortcut, Control C. So in the future, we just do that, right? So if I just do a Control C here, now we're going to need this. We're going to run this command here over and over, a Mona compare command. So you put this here with the address of the ESP. So this is what we're going to keep copying, but with a different stack pointer each time. So let's just paste this in down here and run that. And now here's where we can see the bad characters. Now, there's a lot listed here. We just care about the ones that come first. So we know about the null byte already. We put that in there. 1D is the first one that we need to remove. So I'll just come here, do a Control F for /x1d. And then I'll go ahead and remove that. And then save. And what I should have done earlier was Control F2, F9. To rerun this. And what I'm going to do is update each time I need to update that byte array. That is why I copied this here. So we're just going to run this command to update the byte array. So that is running. And we can just come back here and do Control F5. And now we have a new stack pointer. So this is highlighted, Control C. And over here, we're just going to keep replacing this every time. This is a new value. As you see here, it's different. And we're just going to plug this in. And now we see 2E is the next bad character. So let's just go ahead and update that. So we'll update this byte array here. Control F2, F9. Then come back here. Search for 2E. Remove that, and this is just rinse and repeat at this point. We're just going to keep doing this until eventually it'll say unmodified. That's how you know you got all of the bad characters. So I'll kind of fast forward through this part for you, and you can kind of see what I'm doing, get the idea. I'm just going to be rinsing and repeating this process. And this is what we're looking for here, where the status changes to unmodified. That's how we know we have found all of the bad characters. I know this can be a very tedious process, but it's a lot less error prone than the way the OSCP PDF teaches you to do it. I would highly recommend doing it this way. You'll get faster with it as you practice this more. So now that we've done that, we need to identify a valid jump ESP that we can use within this program. Now, very easy to do that. All we need to do is copy and paste this command here. And then pass it all the bad characters that we determined. And this should find the addresses for us. This will be our new return address. So if we run that, we can take a look. And if this happens to you and you lost the window, just go window, and we're going to look for log data. We'll maximize that. And we see the results down here. There's a jump ESP. We have several options, but whichever one you choose, you got to make sure that it doesn't have any of these mitigations on it. It doesn't have ASLR, rebase, safe, SCH, etc. And so this doesn't have any of the protections on it. This is our address. Now we need to write this in little endian. So this is how we do that. We write the last two, X, the two before that, the two before that, and the two before that. So this is going to be our return address. So if we copy this, we go back to the exploit here. That is what we would put here. And we can go ahead and remove this payload line. So instead of 4Bs, we want to use this return address here. And now we want to actually generate our shellcode that will then run. So what we can do for that is we can use MSF Venom. So MSF Venom, and I already have it here. Awesome. And these are our bad characters. So we're going to tell it what kind of shell we want to do. We're going to use a standard Windows reverse shell, and we will give it our lhost. This is our IP address. Whatever port we want to use. Exit func thread is important as well, so that when you exit it, it doesn't crash the program. Just a nice little thing to add. And then the bad characters, and we're going to put it in C format. And that just makes it really easy for copying and pasting it into this script here. But once it has generated it, what you need to do is just copy from here. I didn't copy the semicolon. Notice that. Just everything in the quotes, essentially, from here to here. Copy this, and I'm going to put it in the payload. Let me backspace out these. I'm going to put parentheses, and then I'm going to paste. Okay? So this is how you need to format it. You need to have it enclosed in parentheses. And that's why I chose C format, because it makes it really easy to do it that way. The Python format is a little bit trickier to work with, so this is the way I prefer to do it. And once we've done that, let's add some no-op padding. So it's typically good practice to pad with about 16 no-ops or so. That way the shell doesn't step on itself, the exploit code, right? That way it'll actually be able to run properly. So once we've added all of those things in, we can save this here. Now we want to start up a netcat listener. So I'll listen on 443. And now that that listener is going, what we can do is we want to restart this first and foremost, Control F2, F9. And now that's running, we'll just go ahead and fire off the exploit by doing Control F5. And when we check this window here, we see we have gotten a shell, and we've successfully exploited this stack-based buffer overflow. So hopefully that helps speed things along for you. I know I did take a lot of time for explanation, so this is not the shortest video in the world, but if I wasn't doing that, then yeah, I could do this a lot faster even. And this is something that's going to take some muscle memory. It's going to take some repetition, some practice, just like anything else. But definitely if you follow these steps, you're going to find yourself blazing through these buffer overflows and getting into the boxes that are worth a lot more points than that, like those Active Directory sets and things like that. So hopefully this helped. Let me know what you think in the comments section below, and go ahead and check out the technical content that I have on screen for you guys right now. Thanks for watching.